Good morning, students. Chapter 5, Laws of Motion. In last lecture we have discussed about some questions. Okay, today's topic is inertial and non-inertial frame of reference. Yes, frame of reference we know from chapter 3. Frame of reference means from where an observer takes his observation. Okay, so yes, that frame of reference. For example, right now I am standing on this table. So for me, frame of reference is this table. If you are in lift, then yes, for you, frame of reference is lift. Okay, if I am sitting in bus, then yes, for me, frame of reference is bus. So yes, it is frame of reference means from where an observer takes his observation. Okay. Now, inertial and non-inertial frame of reference means what? Okay, see, frame of reference, frame of reference, frame of reference, according to motion, according to its motion, it may be stationary. Okay, when you are sitting in bus and bus is stationary, bus is not moving. So yes, related to you, frame of reference is bus and it is stationary. So yes, stationary. Second, accelerated. Third, uniform velocity. Uniform velocity. And fourth one is retardation. And fourth one is retardation. Actually, these 2 and 4, they both are similar. Okay. Now, see, what is inertial and non-inertial frame of reference? What is difference between them? That we will understand with the help of one example. For example, if you are sitting in a bus and bus is stationary, so yes, you will not experience any push in forward or backward direction. Yes or no? If you are sitting in bus and bus is also stationary, bus is not moving, it is not in motion, then will you experience any force, any push in upward direction or in downward direction? No. You will not experience any pull or any push in forward or backward direction. Clear about this? So yes, when a person is sitting in bus and bus is stationary, okay, so he will not experience any push on him. Clear about this? Okay, so yes, he will not experience any push means he will not experience any push in forward direction or backward direction. See, object in rest comes in motion. When some net external forces acting on it. It is Newton's first law of motion. Here, bus is stationary, person is also stationary, no forces acting on object. Yes or no? So it is not moving in forward or backward direction. So we can say here Newton's first law of motion is obeyed. Here Newton's first law of motion is obeyed. Clear about this? So yes, when frame of reference is stationary, Newton's first law of motion is obeyed. Now, second case, if you are in a bus and bus starts quickly, okay, suddenly, okay, not gradually, suddenly, okay, if you are in bus and bus starts suddenly and bus is moving in this direction, then if you have observed, you will experience a push in backward direction. you will experience a push in backward direction. And yes, if you are on active on backside, okay, and if driver suddenly gives accelerator, then yes, vehicle is moving in forward direction, but you will experience some push in backward direction. Yes or no? Yes, if you have observed this. If you have observed this. So see, force is acting on vehicle. Force is acting on vehicle. Bus, for example, bus is moving suddenly in forward direction, then you will experience push in backward direction. Okay, so is there any force acting on you? No, force is acting on bus. Force is acting on bus. Acceleration is given to bus. Bus is moving in forward direction, but you experience force. You experience any push in backward direction. So clear about this? So when bus is accelerated, person feels a push in backward direction. He feels a push in backward direction. Is there any force on person? No, but still he feels a push in backward direction. So here Newton's first law of motion is not obeyed. Clear about this? Okay. Third point, when bus is moving with uniform velocity. Yes, when bus is moving with uniform velocity, it is maintaining its constant speed. Then again, you will not experience any force in in forward direction or in backward direction. Yes or no? If you are moving on constant speed, then you will not experience any force, any push in forward or backward direction. So again, in this case, Newton's first law of motion. Okay, person will not experience any push. So yes, here Newton's first law of motion is obeyed. Newton's first law of motion is obeyed. Clear about this? So yes, first, when bus is stationary, when it is suddenly accelerated, when it is moving with uniform velocity, and last one, when it is retardation. Retardation means when brakes are applied. If bus is moving with full speed, and if driver applies brake on bus, you will experience a push in forward direction. Yes or no? You will experience a push in forward direction. See, brake is applied means friction force, it is acting in opposite direction, but you experience a push in forward direction. Yes or no? Yes. So when it is retardation means if brakes are applied, yes or no, the person feels a push in forward direction. Clear about this? So yes, here when it is retardation, if brakes are applied, person feels a push in forward direction. Again, brakes are applied on bus. Any force is acting on person? No. no force is acting on bus. No force is acting on person. No force is acting on person. Force is acting on bus. Force is acting on bus. Still that person is in motion. Still that person is in motion. So here again Newton's first law of motion is not obeyed. Clear about this? So yes, again we will repeat this whole experiment. When a person is sitting in bus, when a person is bus and bus is stationary, no force on bus, no force on person. So yes, person is stationary. Newton's first law of motion is obeyed. When bus is accelerated in forward direction, force is applied on bus, not person. Still that person comes in motion. It is moving in backward direction. So yes, no force is acting on person. Still it feels some force. Okay. So yes, when bus is accelerated, person feels a push in backward direction. So here Newton's first law of motion is not obeyed, because according to Newton's first law of motion, if there is some resultant force, then it has some acceleration, then it will move. Okay. Third case, when bus is moving with uniform velocity, person will not experience any push. So yes, it is inconsistent with Newton's first law of motion. Last one, when it is retardation, if brakes are applied, person feels a push in forward direction. So yes, here again Newton's first law of motion is not obeyed. So see, out of these 4 types of frame of reference, in stationary frame of reference and in uniform velocity, yes, Newton's first law of motion is obeyed. But in accelerated frame of reference and in case of retardation, Newton's first law of motion is not obeyed. Newton's first law of motion is not obeyed. So yes, what is inertial and non-inertial frame of reference? Inertial frame of reference means in which Newton's first law of motion is obeyed. And non-inertial means in which Newton's first law of motion is not obeyed. How to write? See, inertial frame of reference. Inertial frame of reference. Inertial frame of reference. In which Newton's first law of motion, is obeyed. And non-inertial frame of reference. Non-inertial frame of reference means in which Newton's first law of motion is not obeyed. Clear about this? So yes, these 2 definitions you have to remember. Inertial frame of reference in which Newton's first law of motion is obeyed. See, out of these 4, when bus is stationary and when bus is moving with uniform velocity, Newton's first law of motion is obeyed. So yes, stationary and uniform velocity, it is inertial frame of reference. It is also inertial frame of reference. Clear about this? But when it is acceleration or retardation motion, see, in this case Newton's first law of motion is not obeyed. In this case Newton's first law of motion is not obeyed. So yes, they are called non-inertial frame of reference. They are called non-inertial frame of reference. Clear about this? So yes, now you will be given some conditions in questions. You have to identify which frame of reference you are given. Clear about this? And yes, now a new concept. In non-inertial frame of reference, we have to to consider one additional force called pseudo force, that is Fp, in opposite direction of acceleration of object. Clear about this? So yes, in non-inertial frame of reference, we have to consider additional force called pseudo force Fp in opposite direction of acceleration of object. Clear about this? For example, if it is merry-go-round, okay, we know that acceleration is towards center. Yes or no? So yes, it is accelerated frame of reference. Accelerated frame of reference means Newton's first law of motion is not obeyed, means non-inertial frame of reference, means we have to consider one additional force. And yes, that additional force we have to consider in opposite direction. And yes, that acceleration is called pseudo acceleration. Yes, its magnitude is equal to acceleration of body, but in opposite direction. Okay. Pseudo acceleration is in opposite direction of acceleration of object. Clear about this? So yes, in merry-go-round, if you are in merry-go-round, see again, you will experience some force. Or in car, when car takes a turn, when car takes a sharp turn, okay, if car is turning in this direction, you will experience a force in upward direction. Yes or no? So it is nothing but pseudo force. Clear about this? So yes, it is one case, inertial and non-inertial frame of reference. According to its motion, frame of reference, 4 types: stationary, accelerated, uniform velocity, and retardation. In frame of reference in which Newton's first law of motion is obeyed, they are called inertial frame of reference. In which it is not obeyed, it is called non-inertial frame of reference. In case of non-inertial frame of reference, we have to consider one additional force, that is pseudo force, okay, and it is acting in opposite direction of acceleration. Now, what is pseudo force? How to consider this pseudo force? How to calculate this? We will understand by taking one example. Okay, now we will see one question. See, person with mass of 60 kg stands on a spring balance in a lift. If the lift moves with an acceleration of 2 meters per second square upward and then downward, what will be his weight as recorded? If the cable of the lift breaks, what will be his recorded weight? See, first of all, yes, it is one question, we will solve this, but first of all, I will explain some general cases. Okay, so yes, I can say it is one type of theory. Then we will put value and we will calculate. Okay, so see, here it is. It is lift. On lift, one spring balance is placed, and a person is standing on this spring balance. Now, how spring balance measures weight? See, person having some mass. So weight mg is acting in downward direction. According to Newton's third law of motion, this person exerts force mg on spring balance. So spring balance exerts normal force on it. Yes or no? So yes, here how to measure weight? Okay, a spring balance records weight as normal force acting on person due to spring balance. So here weight is equal to normal force due to spring balance. balance. Clear about this? Okay. Now, in this first case, this lift is stationary. This lift is stationary. Lift is stationary. Stationary means inertial frame of reference. In inertial frame of reference, do we have to consider any additional force? No. Okay. So yes, forces acting on person in this system are due to mass of person mg in downward direction and normal reaction in upward direction. Yes or no? Yes or no? So yes, here when lift is stationary, so weight W is equal to normal force acting on person, and you know that normal force acting on person. Now if you balance this, N is equal to it is mg. N is equal to it is mg. Clear about this? Clear about this? Okay. Now second case. When lift is accelerated upward. When lift is accelerated upward. When lift is accelerated upward. Like this. See. It is lift. Okay. Spring balance. Person. And lift is accelerated upward with acceleration A. You know situation? Okay. Now, yes, during this, mg, that's due to mass of this person, mg is acting in downward direction. Normal force, it is acting in upward direction. Yes or no? Yes, these two forces are common. But lift is accelerated upward. So, frame of reference linked with this person is lift, and it is accelerated. We know that in accelerated frame of reference, Newton's first law of motion is not obeyed. It is called non-inertial frame of reference. In case of non-inertial frame of reference, we have to consider one additional force which is acting in opposite direction of acceleration. Yes or no? Yes, it is. So yes, here it is. Mass of person is m. Okay, if acceleration of lift is in upward direction, the same acceleration a person will experience in its opposite direction. So yes, if acceleration is a and mass of person is m, then it will experience a force ma in opposite direction. Again, lift is accelerated in upward direction. Newton's first law of motion is not obeyed. Non-inertial frame of reference. In case of non-inertial frame of reference, we have to consider one additional force which is acting in opposite direction of acceleration. Lift is moving in upward direction. So yes, the pseudo force, it is nothing but pseudo force. It is acting in downward direction. And yes, mass of object is m. Then mass into acceleration, it becomes force. Clear about this? So in this case, what is weight? Weight is equal to normal force. And see, normal force N is acting in upward direction, and MA and MG, they both are acting in downward direction. So yes, upward is equal to downward. So yes, I can write W is equal to it is mg plus MA. Or I can write M common. Here it is G plus A. Clear about this? Okay. So yes, what is condition when lift is stationary? What is condition when lift is accelerated upward? Okay. Third case, when lift is moving up or down with uniform velocity. Okay. Yes. Lift is moving up and down with uniform velocity. So here, it is lift, same lift. Okay, spring balance, person, lift is moving with constant velocity, uniform velocity means, remember, uniform velocity means no acceleration. Okay, inertial frame of reference, and inertial frame of reference, we do not have to consider any additional force. So yes, there are only two forces, mg in downward direction and n in upward direction. Clear about this? So yes, here weight W is equal to it is n, and yes, here it is mg, and yes, here it is mg. So see, these two cases, These two cases are identical. Yes, when lift is stationary and when lift is moving up or down with uniform velocity, in both cases weight is equal to mg. In both cases weight is equal to mg. Clear about this? Because in these two cases Newton's first law of motion is obeyed. It is called inertial frame of reference. Okay, so yes, out of 4, 1, 2 and 3 cases over. Now one last case, that is when lift is accelerated downward. When lift is accelerated downward, then what happens? See, we will see. Okay, when lift is accelerated downward, the lift is accelerated downward. Lift is accelerated downward. Lift is accelerated downward. Okay, for example, like this. It is lift. Okay, acceleration of lift, it is in downward direction. So yes, we will first of all see numbers of forces acting on person. Numbers of forces acting on person. Mg always in downward direction. Normal reaction always in upward direction. Upward direction means normal to contact surface. Now see here, lift is accelerated downward, means frame of reference is accelerated. Non-inertial, we have to consider one additional force in opposite direction of its acceleration. Acceleration is in downward direction. So yes, that pseudo force is acting in upward direction. Clear about this? Acceleration is in downward direction, so pseudo force is acting in upward direction. Now, upward direction, forces acting in upward direction is equal to forces acting in downward direction. So I can write Ma plus N is equal to Mg. So N is equal to Mg minus Ma. So therefore, weight W is equal to N is equal to, it is Mg minus Ma is equal to, it is Mg minus A. It is Mg minus A. Clear about this? So yes, you have to remember this each and every case. Clear about this? Okay? Clear? Now we will see this question. See here, a person with mass of 60 kg stands on a spring balance in a lift. Okay, so first case, when acceleration of 2 meter per second square upward, for upward, see we have one equation. When lift is accelerated upward, what is equation of weight? W is equal to, it is mg plus A. Yes, you have mass of person, you know what is value of g. Just take value of g is equal to 10 meter per second square. 10 meter per second square. Yes or no? You can easily calculate this. Clear? When same acceleration 2 meter per second square, but it is in downward direction, then yes, we know what is equation. Yes, here it is W is equal to, it is mg minus A. Again, m 60 given, g given, A given. Fine. Calculate these two answers and write your answer in comment box. Clear? Okay. Now we will make some conclusion of this theory. See, what is conclusion of theory? Here it is. If lift is stationary, effective acceleration in downward direction. Okay, effective acceleration. Okay, we will consider four cases. Okay, motion or state of frame of reference. First, when frame of reference is stationary, then effective gravitational acceleration G effective is equal to, it is G. See, here in this case it is W is equal to only mg. When it is in uniform motion, then again G effective is equal to, it is G. When it is accelerated upward, then G effective is equal to, see here it is, when it is accelerated upward, what is equation? W is equal to mg plus a. G plus a. Then what is resultant acceleration? Resultant or effective acceleration, it is g plus a. And when it is accelerated in downward direction, when it is accelerated downward, what is G effective? G effective is equal to, here we see, G minus A. So yes, now you have to remember these four cases. When frame of reference is stationary, effective gravitational acceleration is G. Uniform motion, G. Accelerated up, G plus A. Accelerated downward, G minus A. Clear about this? So yes, it is conclusion of this theory. Now in next lecture, we will solve some questions based on such inertial and non-inertial frame of reference.